Hello, friends. So, as per your request, I have been dealing with gate problems and almost everything we have touched related to gate problems, numericals, theory, and we have explained it conceptually. Tomorrow is your paper, and I wish you all best of luck. All the very best to all of you. Now, related to effective stress and permeability, one of the problem that was in GATE 2001 is quite interesting. It's a very simple chapter. You know how to compute the effective stress. Below the soil mass is going to be the total stress minus pore water pressure. And in permeability also, you have good concept of this at undergraduate level. So this problem of 2001 is given like this. The concrete dam resting over the soil mass, and the base of this concrete dam is given to you as 100 meter. And the soil data that's given over here is the coefficient of permeability Kx, that is in horizontal direction. The coefficient of permeability is Kx, and this is equal to 3.46 meter per day. The coefficient of permeability of the soil in z direction or in vertical direction is 1.5 meter per day. When the flow net is developed for this soil with a scale factor of 1:25 in the vertical direction. So a scale factor is given in the vertical direction. The reduced base length. So you will have to find out the reduced base length of the dam. So the base length of the dam is 100 meter, and you have to find out for the scale factor. But you don't have horizontal scale factor. So how will you find out the horizontal scale factor? Let us see the solution of this problem. So the horizontal scale factor multiplied by under root coefficient of permeability in the horizontal direction Kx must be equal to vertical scale factor multiplied by coefficient of permeability in the z direction or in the vertical direction. So let me find out now this, because this is known to me, this is known to me, this is known to me. Therefore, horizontal scale factor or the scale factor in the horizontal direction will be equal to scale factor in the vertical direction, that is given to me as 1:25. So 1 divided by 25. So this part is given to me multiplied by the coefficient of permeability Kz is given as 1.5 meter per day, and if you take it in denominator, this Kx value, then the Kx value is given to you as 3.46 meter per day. Therefore, the scale factor in horizontal direction can be computed. So let's calculate this. If you calculate, The horizontal scale factor is calculated as 0.026. Up to 3 decimal places we will take it. Now, having got the horizontal scale factor, the reduced base length, therefore, the reduced base length of the dam can be calculated. So reduced base length, if you multiply it by 100, is the reduced base length becomes 100 meter multiplied by horizontal scale factor, that is 0.026. So it becomes 2.63 meter. So 2.63 or 2.6 meter. So when you multiply it, this becomes 2.63 meter. So his simple problems are being asked. If you see the gate problems on effective stress principle, I have seen that the questions are asked from the to calculate the effective stress in the soil mass, and also due to capillary action. So due to capillary action in the soil mass, when the water is going to rise, so if it is the ground surface and the water is a groundwater table is given to you, and if it is going to be saturated above the groundwater table due to capillary rise, you know that in this zone there will be negative pore water pressure, and the negative pore water pressure, if the height is given to you as h, then the negative pore water pressure is going to be like this. So there is the hydrostatic pressure here, 0 at the top of the groundwater table. So hydrostatic pressure, and here it is the negative pressure, negative pore water pressure will be H into gamma W. So the value here is, it is maximum, and as you go and come to the groundwater surface, the negative pressure becomes 0. So this UW is minus H into unit weight of water. So what is the height? So this concept, therefore, what happens in this zone is, if you want to find out the effective pressure, so effective pressure is going to be total pressure minus pore water pressure. Now, in this zone, the hydrostatic pressure is going to be positive. So pore water pressure due to water is going to be positive. So you can have the negative sign. But in the capillary zone, or due to capillarity, or due to pore water pressure is going to be minus negative. So here, due to capillarity, the pore water pressure becomes negative. Therefore, the effective pressure is going to be positive shear. So the total pressure plus the due to overburden, and this is going to be positive. So your effective pressure here uh, below the natural groundwater surface, it is going to be negative. So it is going to be less than gamma t, whereas in the um, capillary zone, it is going to be additive, and therefore this is going to be higher. So these are some of the simple things that in effective stress principle you can learn from my book also. My book is there, Geotechnical and Foundation Engineering, published by Charotar Publication, Anand. That book I have dealt in detail about this. And tomorrow is your examination. So I can say at this stage, best of luck to all of you. And many of you have requested that I should also take up the problem of engineering services examination. And my next video will be questions pertaining to engineering services examination. So those aspirants or those students who are preparing for UPSC examination will be greatly benefited. So with this, friends, I say best of luck to all of you, and thank you very much. And I hope you will be able to fare very well in the examination. All the best to all of you. Thank you.